Rule for definite integrals. Okay, and then we'll go back to close up whatever we forgot. We didn't get the chance to look at. Okay, would you like to look at an indefinite integral first with the substitution rule?
Sure.
Okay, so let's do that. Let's say 16 on 413. Just to refresh our memory.
Is this 5.5?
Yes, e to the x, cosine e to the x, dx. Okay, any ideas about this?
Yes.
Yes, we will denote e to the x by, why? Because e to the x is inside another function. So if I could get rid of this and just have a variable here, it would be much easier to handle, right? Which variable we want to use, it doesn't matter.
Yeah.
We want to say, let u be e to the x. Only if du is in the problem, with minor plus or minus a constant, and that's okay. So is du in the problem?
Yeah.
Yes. How much is du?
You did x and dx.
Excellent. Please remember, du must be f prime times dx, which it is. Now you notice that this piece and this piece are exactly what we need. So can anyone express this integral? So it will be u du. Do you all see it? Which function prime is cosine u? Careful. Sine u plus a constant c. And now we have to go back and write sine e to the x plus a constant c. These are the steps for substitution rule for indefinite integrals. Any questions?
So that's
Right here.
where's the negative in front?
Sine prime is cosine. That's okay. Yes, Brayden?
Would it just be cosine du, not cosine u du?
But cosine without an argument doesn't mean anything. If I tell you cosine, you'll say, so give me an angle. Cosine means nothing without an angle. So cosine without the argument means nothing. Here it was cosine of this, cosine e to the x. That's the argument. So if I don't replace the argument by something, then cosine means nothing. If you say to me cosine, I'll say, Okay? Any questions? Okay, so let's look at definite integrals. Definite integrals using substitution. Okay, we are on page 414. Let's start with, let's say, 56. The integral from 0 to 3 dx divided by 5x plus 1.
Is it on the same page?
414. Remember this, there is a requirement here. Very important requirement. F of x must be continuous on the interval 0, 3. If the function is not continuous on this interval 0, 3, we cannot determine the integral. The fundamental theorem of calculus is not applicable. Yes, Savannah?
Are you sure that the sine of x is negative cosine? I mean, are you sure that the prime of cosine is sine and minus?
That's not what I'm asking. I'm asking which function prime is cosine.
Okay. Okay. Yeah, that's.
So when we integrate, we're going backwards. We're asking ourselves which function prime is cosine. Is that better?
Yes.
Perfect. Other questions? Don't let me move on if you have questions, please. Okay, is this function continuous on the interval 0, 3? You could say, I don't know. Well, the only thing I can say is that 5x plus 1 cannot be 0 and x cannot be negative 1/5. Yeah, it is continuous. The function is discontinuous at -1/5, but -1/5 is not on the interval 0, 3. So yes, this condition is fulfilled. So this is extremely important to always check when you determine a definite integral. You have to make sure that the function is continuous on that interval. So for example, if I ask you to find the integral from -2 to 4 from 1 over x dx, you must write fundamental theorem of calculus not applicable. You have to wait till Calc 2.
Because x can be 0.
Exactly, and 0 is in the domain or in the interval -2 to 4. Is that clear? Okay, so coming back to our problem, I'm going to copy it here one more time. So this integral is 0 to 3 from dx 5x plus 1. I'm going to say let u be 5x plus 1. So how much is du? Not only 5, but
5x plus 1 dx.
5 dx. Awesome. Do I have 5 dx in the problem? No, but it's a piece of cake to make that up. I don't have the 5, but I can always multiply and divide by 5. This is 1.
Can you explain that?
Yes, I need a 5 dx, but I only have dx. So I'm going to multiply by 5 and divide by 5.
How you got du?
So this is a function. This is f of x. So when I find du or dy in this case, I have to write f prime of x dx.
Okay.
This function prime is 5, and then I have to write dx.
Okay, that makes sense. Thank you.
Better? Yes,
Yeah.
Ricky?
So that's how you got 5 dx is f 5x.
Yes, yes. This is what we did last time. So let me just show you. So in all these problems, right? So we determine we use a substitution y equals cosine x, and that's what we did, right? dy equals negative sine x dx. So it seems that we are surprised, and I'm not sure. Is this clear? Was it clear from last time? Is that okay, everyone? Yes? We've seen this before. Okay, just making sure. Okay, so then I really needed the 5 because I need 5 dx. I multiplied by 5 and divide by 5. This will be denoted by or replaced by du. This will be replaced by u. There is a 1/5 in front. Do not write the limits of integration. So what do we have inside? Forget about the limits for a moment.
Du.
Over. Very good. Now keep in mind, these limits of integration from 0 to 3 are for which variable?
Dx.
Not with dx is not a variable. For x. So when x is 0, what will be the lower limit for u?
1.
Thank you very much. When x is 3, what will be the upper limit for u? Excellent. You understand that you cannot no longer you cannot copy the limits of integration for x once you change the integral into a different variable. So what is available or what is given to us for x is not the same for u. We created a new function. Yes,
I
right?
thought you plugged in 3 for the upper limit and then subtracted.
I'm not there yet. I haven't determined the antiderivative yet. So I started with the limits of integration for x. I changed the integral from x to an integral in u. I cannot copy the limits of integration for x. I don't have x. I have u. So when x is 0, the lower limit becomes 1 for u. When x is 3, the upper limit becomes 16. Now we are ready to write the antiderivative. Which function prime is 1 over u? Which function do I differentiate to get 1 over u?
U to the negative.
It's the only one without the power. Which function is that? So which function prime is 1 over u? Say it again. Very good. Natural log of the absolute value of u from 1 through 16. Excellent. Please remember this is natural log u, but we have to write absolute value. Okay, so this is 1/5. Now we are plugging in 16. So natural log 16, there is no need of absolute value. And really there is no need to plug in 1 because natural log 1 is 0. Natural log 1 is 0. Natural log e is 1. But natural log 1 is 0. So the answer is natural log 16 divided by 5. And if you say go back and check, I'll say sorry. All I can do is do it again from the beginning, and hopefully I get the same answer. But this is not an indefinite integral in which I could say, okay, let's differentiate both sides and we'll check the answer. Nope, it doesn't work that way. So let's summarize the difference between substitution rule for indefinite and substitution rule for definite. Right? For an indefinite integral, I must go back and put in the previous function in. It's a must. But for a definite integral, what do? Once I move from x to u, I don't have to go back ever because I have to change the limits of integration. From the limits given for x, I have to change or determine new limits for u. And we do not need to go back to the previous variable. Okay, this was one example. Let's take a look. Let's say 60. The integral from 0 to 1, x e to negative x squared dx. I have to caution you, or maybe just say that we are not always able to find the antiderivative. We can't, algebraically, not always are able to determine the antiderivative. Software and computer systems may be able to, but not us. So, can I still, bless you, can I still get an approximation of this? Yes. How? Use 4 subintervals with the leftmost point, midpoint, or the rightmost point, and you will get an approximation. Pretty good approximation. If you use 8 subintervals, you get a better approximation. But you can always determine some approximation of a definite integral, even if you cannot determine the antiderivative, which will not always happen. Very good. So then, what do you think we're going to do? Any suggestions? Of course, I'm going to check whether the function is continuous between 0 and 1, that x is continuous between 0 and 1, e to the x is always continuous. So there is no problem here. So then I will say let y be. What bothers you? I know it's not the scientific way, but what is weird here? E is so friendly. Exactly. That is what I don't like. I prefer to see e to the y. I don't really like to see e to negative x squared. Good. But now I have to have dy in the problem. What is dy equal to?
Negative 2x.
Very good. dx. Do I have negative 2x dx in the problem? I have what is important. I have x and I have dx. I don't have negative 2. So what? I multiply by negative 2 and divide it by negative 2. That doesn't make any difference. It's just 1. Now, can anyone give us the new integral? Do not write the limits of integration. Do not copy the limits of integration. So please give us, of course, there is a negative 1/2 in front. The integral from what? I cannot copy the limits of integration. Leave the limits of integration alone for a moment. So just tell me what we have here. e to y dy, e to y dy. This is e to y, and this is dy. E to y dy. Now let's discuss the limits of integration. When x is 0, what is the lower limit for y? Excellent. When x is 1, what is the upper limit for y? Careful. -1. Perfect. So what function prime is e to y? What function do I differentiate to get e to y? E to y, of course. From 0 to -1. -1/2 stays outside. We plug in -1, e to -1, and we subtract when we plug in 0. But how much is e to 0? Excellent. So this will be -1/2 in parentheses 1 over e minus 1. You can distribute -1/2, -1 over 2e plus 1/2. And I just remembered that I wanted to show you one more property of the definite integral. The integral from a to b from f of x dx is the opposite of the integral from b to a from f of x dx. So please edit in. This is another property of the definite integrals. Okay, let's practice some more. What about 62? The integral from 0 to pi over 2.
Can we slide the
The integral from 0 to pi over 2 from cosine x multiplied by sine applied to sine. Sine applied to sine times dx. Okay, another definite integral. What should we do here?
Denote the sign in parentheses.
Excellent. That's what I don't like. I don't like this inside another function. So let's say, let t be sine x. You choose the letter, just don't choose x. As long as dt is in the problem or easy to make up, plus or minus a factor.
Cosine t dx.
Very good. Cosine x dx. Excellent. Is dt in the problem? It's right here. This is our dt. Do not copy the limits of integration and please tell me what to write. That's it. Sine t dt. This is sine t, and this is dt. When x is 0, how much is low limit for t? The lower limit for t when x is 0. 0, very good. Pi over 2. When x is pi over 2, what will be the upper limit for t? Excellent, 1 indeed. Which function prime? Which function I differentiate to get sine? Yes, negative cosine t from 0 to 1. Remember, these are radians. Leave the negative outside. In parentheses, cosine 1. I have no idea what that is. It's cosine 1 radian minus, when I plug in 0, I get, which is 1. Very good. All I have to do is just distribute. So negative cosine 1 radian plus 1. And that's the final answer. I forgot to mention, but we can never ever forget, is this function continuous on 0, pi over 2? Yes, it is. Sine is continuous everywhere. Sine is continuous everywhere. This sine is continuous everywhere. Cosine is continuous everywhere. Yes, fundamental theorem of calculus is applicable. Yes, Braden?
Where did the sine t dt equals negative cosine t come from?
The antiderivative. When I differentiate this function, I get this function. When I differentiate cosine t, I get negative sine t with minus in front will give us the sine. Is that better?
No, because the sine t is not in the problem. I just don't know how that's coming.
It's right here.
I just don't know how we got that.
So we denoted this by t. So then I have sine t. Sine, this is t. This is t. So this is sine t. And I copied it here. These two are dt. Cosine x dx is dt. So this piece is sine t. And these two together are in dt.
But we're multiplying that.
Yes, and I can rearrange them the way I like. 2 times 3 times 4 is 4 times 2 times 3 is 3 times 2 times 4 is whatever I want to do. I can rearrange this in any form I want. I can put dx here. I can put cosine here. I can swap these two. I can do whatever I want because it's a product. So then I put this in front, and then this product is here. Is that better? Perfect. So let's look at another. 66 caught my eye. Same page. The integral from negative pi over 3 to pi over 3, x to the fourth, sine x dx. Few questions here. Is this function continuous on negative pi over 3 to pi over 3? The answer is yes. X to the fourth is continuous everywhere. Cosine is continuous everywhere. No problem. I noticed something very important. I noticed a symmetric interval. Every time I notice a symmetric interval, I ask myself, is this function, is it odd? If it is, I'll write 0. If it is even, then I'll write twice from 0 to pi over 3.
Even.
The function is odd. This piece is even, but this piece is odd. So yes, so odd is stronger. Yes, of course. Odd dictates. Yes.
Wait, why is it odd?
Okay. So we are talking about a function that is x to the fourth times sine x. In order to show or determine whether the function is odd or even, what do we need to find? F of negative x. Excellent. Negative x to the fourth, sine negative x. How much is negative x to the fourth? X to the fourth. There is no change. But now how much is sine negative x? And the answer is negative sine x. And when I perform the product, I get negative x to the fourth times sine x, which means negative the original function. So it is, indeed, the function is odd. So then I don't have to do anything. And what will the answer be?
0.
Excellent. The answer is 0. And I have to explain why. Vanessa?
So you said if it's odd, it's automatically 0?
Yes.
Okay. What about
And if it's a symmetric interval, two conditions have to be fulfilled. Symmetric interval and odd function.
so what if it's even? And it's symmetric?
The properties were last time, so it's twice from 0 to. Yeah. So if it's odd, the answer is 0. If the interval is symmetric and the function is even, then I will have twice the integral from 0 to pi over 3. Any questions? Yes, Ricky?
So if the domain is symmetrical,
The interval. I'm not saying that this is the domain of the function. I'm saying the interval.
so the interval is symmetrical, it's fine. It's even odd.
We should always look. Yes. Yes.
Are all functions odd or even?
No. No. So very good question. So here it is. This function, for example, f of x equals x to the third plus x squared is none of the above.
Because
It's not odd, it's not even. Any questions? So it's nice when functions are symmetric, but it doesn't always happen. Okay, next one. Please choose anything you want. I'm looking at 67. Please choose the next one if you'd like. In 67, we have the integral from 1 to 2. From x, the square root of x minus 1 dx. Is this function continuous on 1, 2? Yes, because the domain of this function is x minus 1 greater than or equal to 0, x greater than or equal to 1, and it's continuous everywhere. Good. From 1 to 2, I meant. Good. So then, any suggestions how to proceed?
C.
Okay. We want to use C. We normally don't use C because of C is a constant. But we can use anything else. E we don't really use because of E. Okay, let's use D.
X minus 1.
Okay, so D equals x minus 1. Now I'm having a little bit of a problem with DD, but let's say, what is DD equal to?
1 for each dx.
Exactly, very good. Perfect. So then, do not write the limits of integration. Yes, Vanessa?
Where did the first x go?
When I differentiate x minus 1, I get 1. I didn't get there. You mean this one?
Yeah.
Oh, we didn't get there yet.
Okay. Okay.
You're right. We didn't. I thought you were talking about this one.
Okay.
Sorry.
Okay.
Okay, so I think we should change the variable from D to something else. Okay, let's make it W. So W is x minus 1. So dW equals indeed dx. Good. What do I replace this by?
W.
square root of
Very good. What do I replace this by? Very good. And now, what do I replace this by? W plus 1. This is W plus 1. Perfect. So W plus 1 times the square root of W times dW. Excellent. See how good he is if he pays attention?
Extra credit?
Okay. Okay. When x is 1, what is the lower limit for W?
0.
Excellent. When x is 2, what is the upper limit for W? Excellent. I have to distribute. I have to distribute, and I will rewrite the integral from 0 to 1 from W 1 plus 1/2. The square root of W is W to 1/2. So I get 3/2 plus W to 1/2. Let's look at this for a moment and see if you have questions. I'm distributing W to 1/2 to W. Copy the base, add the exponents, and we get 3/2. I'm distributing W to 1/2 to 1, and I get W to 1/2. Is everyone okay with this? Yes, everyone? Yes? Okay, so now I need the function that I differentiate to get W to 3/2. 3 over 2 plus 1 over 3/2 plus 1 plus W to 1/2 plus 1 over 1/2 plus 1. You can skip this step. I just wanted to show everyone. Yes, Vicky?
is plus one in the exponent?
Of course.
Okay.
Remember, it's x to the n. The integral from x to the n is x to n plus 1 over n plus 1. Yes, it is at the power. Yes. Good. So 3/2 plus 2 is 5/2, and I have to flip that, right? So 2/5. W to 5/2. The denominator is 3/2, so it's plus 2/3 W to 3/2. And we are happy because we only have to plug in 1 in this mess. Yes, please? Anything?
I'm not sure where you got the denominators from and the first one.
This one?
Yeah.
The rule is x to the n, the integral of x to the n equals x to n plus 1 over n plus 1.
Okay.
Better? We remember that? Okay, so we are lucky because this was 6 and this is 7. We're lucky because we only plug in 1. So this is 2/5 plus 2/3. The least common denominator is 15. And please tell me how to adjust the top. What do I do? I multiply the top of the first fraction by 3 and the top of the second fraction by 5.
3 times
Yes, so it's going to be 6 plus 10. So this is 16 over 15. And this is final. And if you say go back and check, I'll say sorry. All I can do is start from scratch and do it again. There is no way I can check the answer. Okay, any other preference from any of these? Or we go back to the last item, Fundamental Theorem of Calculus, Part 1. Do we need to look at more substitution?
Yes.
Perfect. Yeah, I'm looking at 69. And 69, we have the integral from e to e to the 4th from dx over x, the square root of natural log x. Okay, something has to go away.
That's a lot.
Yes, I agree. Let y be natural log x. But only if dy is in the problem with minor adjustments. I can always make up a factor, but I cannot make up x or natural log or the square root of x. I can't. 1 over x dx. Do I have 1 over x dx in the problem? I do. Excellent. So do not copy the limits of integration, please. And tell me what you have.
1
So dy over?
square.
Yes, the square root of y. Excellent. Dy over the square root of y. Good. Now the limits of integration. Carefully. When I plug in e to determine the lower limit for y, I start with the lower limit for x. The lower limit for x is e. I plug it in, and I want to determine y. Natural log e.
1.
1.
Excellent. Yes, Ricky, you had a question?
So it's not 0?
Natural log e? No. Natural log 1 is 0. Natural log e is 1. You want me to write this down? Okay. So now let's plug in e to the 4th.
4.
Yes, natural log e to the 4th is 4 indeed. Excellent. So now let's rewrite the function one more time. The integral from 1 to 4, y to negative 1/2 dy. This is easier. Yes, please.
I'm
Really?
confused how before we got dy over square root y.
Here.
Yeah.
So we denoted this by y. So this must be the square root of y. I can't remove the square root. I only worked inside and I replaced this by y, so the square root has to stay. So 1 over x can be written as dy over x. Dy over x. Better? Good. So then this is y to negative 1/2 plus 1 over negative 1/2 plus 1 from 1 through 4. Is this clear, everyone? Yes? Okay, so let's simplify the powers. So negative 1/2 plus 1 is 1/2, so this must be the square root of y. And negative 1/2 plus 1 is 1/2, so it's a 2 in front. Nice. From 1 to 4. Leave the constant outside. Please plug in 4 and tell me what you get.
4.
2 minus, please plug in 1 and tell me what you get. Very good. How much is 2 minus 1? Times 2? 2. Very good. Would you like to choose more? Or would you like me to choose more?
So is the 2 a constant?
This one?
Yeah.
Yes, it comes from here. Negative 1/2 plus 1 is 1 over 2 that I have to flip. 2 over 1. It comes from the denominator.
So if you plug in 4, would it be square root of 4 times 2?
But I left the 2 outside. So the square root of 4 is 2, minus when I plug in 1. I perform this operation and get 1 and then multiply by 2.
Okay. But if you did it that way, would you get the same thing?
Of course, yes. Because when you plug in 4, then you have 2. 2 times 2 is 4. And then when you plug in 1, it's 2. And 4 minus 2 is still 2. But it's always, again, it's up to you. But it's always easier to leave the constants waiting outside. Let me perform the operations and not worry about that. And when I'm done, I'll multiply by 2. But again, this is just a suggestion. You will get the same answer. It's up to you. Whatever works for you. Would you like me to continue with some more problems?
Yes.
Yes? Okay. So let's take a look. 68. In 68, we have the integral from 0 to 4. From x over the square root of 1 plus 2x dx. Always remember, I forgot to say it here on the previous problem, the integral from e to the fourth, this is not 0, right? Between e and e to the fourth. And is this 0? It has to be greater than 0 and also not 0, right? Strictly greater than 0. So when I have e, I get 1, and then 1 minus, so the top would be between e and e to the fourth, this is a positive number. Good. So what do you think we should do with this problem?
To know 1 plus, or square root of 1 plus 2x. Or just
It's
1 plus
possible.
2x.
Why not? Let's try. Let's try and see if it works. So Braden suggested not just 1 plus 2x. He said, let's get rid of 1 plus 2x with a square root. It may work. There may be more than one substitution for several problems. Let's see. Let's see what we get. Then we can stop and say, no, 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 no. Maybe this is not the right way. And we'll go back and make a change. But let's give it a shot. Okay, so is dy in the problem?
Yes.
Yes, it's 1 over 2 the square root of 1 plus 2x times the inner function prime times? Excellent. So then I simplify, and look at that. So dy is basically dx over the square root of 1 plus 2x. So then all this becomes dy. Now I have to worry about that. So I have to solve this equation for x, because I have to replace it up here. I cannot have x and dy and y in the same problem, in the same integral. So how will I solve this equation for x? What should I do to both sides to solve this equation for x?
Square.
Yes, Vanessa?
I have a question.
Yes?
I'm not sure where you got the dy from. The first dy.
Okay, so if this is a function and I differentiate it, I get 1 over 2 the square root times the inner function prime.
Okay.
Better?
Yeah, and then you just put the dx. in
I
there.
have to because I'm determining dy.
Okay.
I'm not determining y prime.
Okay.
Better? Everyone? Okay, perfect. So then, again, what type of equation is this? You already said it, but I was answering, so I want to make sure that everyone heard that. Yes, it's a square, it's a radical equation. So how do I solve it?
Square root.
Very good. So I have y squared equals 1 plus 2x. Then subtract 1 and divide by 2. So x equals y squared minus 1 over 2. So this x gets replaced by y squared minus 1 over 2. Now please dictate the new integral. Do not copy the limits of integration. They don't work anymore. So we will have,
Y squared minus 1
excellent, y squared minus 1 over 2 times,
dy.
excellent. Great job. But now we need the limits of integration. When y is 0, which is the lower limit for y, what do we get?
Negative 1.
So this is 0. The square root of 1 is 1. So the lower limit for y is 1. Let's plug in 4. When we plug in 4 for x, we should determine the upper limit for y. Excellent. Very good. Of course, I'm going to pull 1/2 outside. I don't want it. I don't want to see it till I'm done. It can wait patiently. So 1/2 outside. Please tell me what function prime is y squared? Y cubed over 3 minus which function prime is 1?
X.
Oh, yes, but it's, in this case it's y. Very good. From 1 through 3. Well done. What do I do next? I plug in 3. 3 cubed is 27 divided by 3 is 9 minus 3. Minus, be very careful now, plug in 1 and we get 1/3, but I have a minus, so I have to change it. Let's better put it in parentheses for everyone to see what we're doing. So we plugged in 3 and we got this, but now minus when I plug in 1, so I get 1/3 minus 1. So this is f of the upper limit and this is f of the lower limit. F of b, f of the upper limit, which is f of 3 minus f of 1, which is all this. So then 1/2 stays outside still. So this is 6 minus 1/3 plus 1. And this is 7 minus 1/3. So 21 minus 1 is 20. 1/2 times 20 over 3, which turns out to be final 10/3. Yes, get used to a lot of arithmetic with these definite integrals at the end. A lot of work.
So I have a
Yes.
question.
Yes.
How come it's not negative 1/2 instead of?
You mean the one outside?
Yeah. Because
Let's-
it's negative 1/2 is the first. So when it's y squared minus 1 over 2, right there where your name is at the bottom.
I did not remove anything from the top. I only removed 1 over 2.
Right, so when you get down to that part and you make it 1/2, why
Yes.
is it not negative? Because there's a negative sign in front of 1.
Right, but I did not separate the fraction. I only removed 1 over 2 and put it outside. I kept y squared minus 1 unchanged. Is that better? So let me show exactly what I'm saying. So if I have x minus y over 3, I can rewrite this as 1/3 times x minus y. That's what I did.
Oh, I got you. Okay.
So then it's a very good question actually. When I write this, I have 1/2 and y squared minus 1. So I did not change the numerator. I only changed the fraction into a product. 1 over 2 times the numerator. Better? Perfect. A very good question. Thank you. Okay, next. Do we need more examples, or now we are ready? This section 5.5 is finished. I don't have anything else to teach you here. So I would like to go back to, we can look at more problems from page 404 with definite integrals, if that's what we like, but there is no substitution involved. There is no need for a substitution. I think we should, for now, go back to Fundamental Theorem of Calculus Part 1, and then we'll practice some more. Yes, questions? I did copy for you a test 4. I know we decided to have our test 4 at the end of next week, so we will have to review on Tuesday, or even if we have time, we'll start today. 1, 2, 3, 4, 5. Thank you. 1, 2, 3, 4, 5. So please work on these problems as soon as possible. And as I said, we can start today if that's what you want. So let's go back to Fundamental Theorem of Calculus Part 1. So what I say it again, Ricky? It's 5. It's in 5.4. The Fundamental Theorem of Calculus is in 5.3. Sorry. So in some books, this would be called Part 2. Not important. Just remember, one part shows that differentiation and integration are inverse operations, and another part is teaching us how to determine a definite integral. It doesn't matter how it is called, if it's called Part 1 or Part 2. So Fundamental Theorem of Calculus has 2 parts. One of them shows us how to determine a definite integral, and the other one shows that the differentiation and integration are inverse operations. That's all it means. Okay, so let's discuss a little bit of a preliminary. So if I say when x is 1, y is 2. And then when I say x is 0, y is 1. And let's say I say x equals -2, y is 5. What am I creating here? Okay, a function. This is a function. Can anyone figure out which function I used?
X squared plus 1.
Of course, our best friend. Our best friend x squared plus 1, of course. And you can say, what does this have to do with what we are trying to do? Just keep this in mind for a moment. Okay. So now, let's look at our function f of x. Our interval, of course, a comma b. And I would like you to tell me, what does this represent?
Area under the curve.
Correct. The
Integral
from
A to B.
from f of x dx. Awesome. Great job. Now, stay with me. Here's my next question. I'm going to say that this is x. I just picked anywhere between a and b. So I'm going to say x is anywhere between a and b. You can say, I don't want it here, I want it closer here. Fine, I want it here. It doesn't matter where, anywhere you want between a and b. Now I would like you to tell me what this represents. Just this piece. Very good. From? Excellent. So now I'm giving you a numerical example because we need to understand this. Let's say I have between 1 and 4. If I plug in Unfortunately, I have to change the variable. Sorry. You'll see in a minute why. So this is f of t. This is the function f of t. This is the integral from a to b from f of t dt. X is correct. Everything is fine. X is between a and b. But this is f of t dt. And now finally my question. Let's say when x is 1. X is 1. What will the integral from a to 1 from f of t dt be? Nobody knows. A number.
Positive number.
Yes, because the function is positive. What about 1.2? What will the integral from a to 1.2 of f of t dt be? Well, another number. So then, can anyone tell us what does this represent? If I can plug in x, and every time I plug in a different x between this number and this number, I get a different number. What does this represent then? Excellent. It is a function of x. So this is not just one number. For any x, I will get a different number. Because of that, because for every x, I get a different number. For this x, I get this number. For this x, I get this number. We created a function. But this function, and we have never seen this before, is given as an integral. Yes, you still don't see where I'm what I'm getting at. In a moment, you will. So a function given in the form of an integral. It's still a function. So the function is g of x, the integral from a to x from f of t dt. I cannot use x and t in the problem because x is the number that goes from a to b. That's why I needed a different variable. Okay, now the moment of truth, final step. What do you think we can do with this? No, we are not going to be asked to determine this. No, that's not possible. No one can determine this. It's a function of x. What we can be asked to do is find g prime of x. Okay, that's all we are asked to do. We are given a function in the form of an integral, and we are asked to find its rate of change, its derivative. But what did we say will happen when we differentiate an integral? A long time ago, which was last Tuesday, we said that when we differentiate an integral, what will happen? When I differentiate an integral, this piece goes away, this piece goes away, and I get the function. Exactly. F of x. That's exactly what happens. And that's part one. That's it. And now we're going to be given functions in the form of integrals to differentiate. That's it. Yes? When we differentiate an integral, we get the function. Yes. Yes. So you'll see how this works in just 1 minute. Let's look at page 394. Let's start with problem 7, 394. We are given a function g of x. It's the integral from 1 through x, because it's g of x, it has to have x in it. And the function is 1 over t cubed plus 1 dt. We are only asked